Scene script. Have you ever wondered how far science can miniaturize technology? Welcome to the fascinating world of nanoscience and nanotechnology. In the grand scheme of things, we humans are quite small, aren't we? But when we dive into the realm of nanoscience and nanotechnology, we realize that we're actually quite colossal. So, what do these terms mean? Nano, derived from the ancient Greek word for dwarf, refers to 1/1000th of a meter. That's like comparing the size of a marble to that of the Earth. Mind-boggling, isn't it? Nanoscience, as the name suggests, is the study of particles and structures that exist in this incredibly small scale. It's like delving into a whole new universe, where the laws of physics as we know them begin to change. Nanotechnology, on the other hand, takes this knowledge and applies it to create new materials and devices. From medicine to computing, this tiny tech has the potential to make a gigantic impact. Now let's try to grasp the scale of nanotechnology. Imagine a single strand of your hair. Seems pretty small, right? But in the nano world, it's a giant. A human hair is approximately 80,000 to 100,000 nanometers wide. To put it in perspective, if a nanometer were somehow magnified to appear as long as the nose on your face, then a red blood cell would be the size of the Empire State Building. So we're talking about a scale that's almost unimaginably tiny. But don't let the size fool you. The world of the nano is a place of immense potential. It's a frontier where we're still mapping the terrain, still discovering the possibilities. It's a place where science fiction blurs into science fact, where we have the power to manipulate atoms themselves. So in essence, nanoscience and nanotechnology are all about studying and manipulating materials at an incredibly tiny scale. Now, let's dive deeper into what nanoscience is all about. Nanoscience is the exploration and understanding of phenomena and material manipulation at an incredibly small scale. How small, you ask? Imagine taking a meter and dividing it into a billion tiny parts. Each of these billionth of a meter is what we call a nanometer, and that's the scale we're talking about when we delve into nanoscience. At this nanoscale, the world as we know it gets a bit quirky. The physical, chemical, and biological properties of materials begin to change. They start to differ in fundamental and often valuable ways from the properties of individual atoms and molecules, or even bulk matter. It's like stepping into an alternate universe where the rules of the game have changed. Suddenly, gold isn't just gold anymore. It could appear red or purple, depending on its size. And carbon isn't just the stuff of pencil leads. It could become a super strong, super light material known as a carbon nanotube. This might sound like a science fiction movie, but it's actually happening right now in labs around the world. Scientists are using nanoscience to create new materials and systems with unique properties. They're manipulating matter at the atomic and molecular scale to build nanoscale devices for a variety of applications. But why does all this matter? Well, understanding these changes at the nanoscale opens up a world of possibilities. It could lead to breakthroughs in medicine, energy, information technology, and many other fields. So, if you've ever wondered why your smartphone is getting smaller yet more powerful, or how scientists are developing targeted drug delivery systems, or even how solar panels are becoming more efficient, then you've already been touched by the magic of nanoscience. That's the crux of nanoscience, understanding the unique phenomena that occur at the nanoscale. It's about taking our understanding of the world as we know it and pushing the boundaries of what's possible. And that's just the beginning. Because as we continue to explore this tiny universe, who knows what we might discover next? Having understood nanoscience, it's time to explore the practical applications in nanotechnology. Nanotechnology is the application of nanoscience in creating new materials and devices at the nanoscale. This field is the marriage of the theoretical knowledge of atoms and molecules with the practical ability to manipulate them for specific purposes. Consider medicine, for instance. Nanotechnology is changing the face of healthcare. It's used in targeted drug delivery, where nanoscale robots known as nanobots are deployed to deliver medicine directly to diseased cells, minimizing side effects. It's also used in the development of nanoscale biosensors that can detect diseases at their earliest stages, long before they become dangerous. Switching gears, let's talk about electronics. Nanotechnology is behind the miniaturization of electronic devices we've seen over the past few decades. Thanks to nanoscale transistors, we've gone from room-sized computers to devices that fit in our pockets. And it doesn't stop there. Nanotechnology is now paving the way for quantum computers, which promise to be millions of times more powerful than today's supercomputers. In the realm of materials science, nanotechnology is creating materials with remarkable properties. Consider carbon nanotubes, which are stronger than steel, yet lighter. Or aerogels, the world's lightest solid materials that are excellent thermal insulators. These nanomaterials are revolutionizing industries from aerospace to construction. Finally, let's discuss energy production. Nanotechnology is improving renewable energy by enhancing the efficiency of solar panels and wind turbines. It's also enabling the development of more efficient batteries and fuel cells, which are crucial for the transition to a sustainable, carbon-free future. So, whether it's curing diseases, shrinking electronics, creating revolutionary materials, or improving renewable energy, nanotechnology is indeed revolutionizing our world. It's a testament to the power of thinking small to create big changes. From curing diseases to improving renewable energy, nanotechnology is truly revolutionizing our world. But did you know, nanoscale phenomena are not just confined to science labs? That's right. The wonders of nanotechnology are not limited to sterile research facilities. They're all around us, woven into the very fabric of nature itself. Take, for instance, butterfly wings. These delicate structures are not simply pigmented, but rather, their iridescent colors are a result of nanoscale structures on the surface of their wings. These structures interact with light in a way that produces the dazzling array of colors we associate with these beautiful insects. It's nanoscience in action, right before our eyes. But it doesn't stop there. Have you ever wondered how a lotus leaf remains clean and dry, even in the muddiest of waters? This is due to the nanoscale structures on the leaf's surface, creating a water-repellent or hydrophobic effect. Water droplets simply roll off, taking dirt and debris with them, and leaving the leaf spotless. This phenomenon, known as the lotus effect, has inspired numerous applications in nanotechnology, from self-cleaning paints to water-resistant clothing. Now, let's move from the serene lotus pond to the side of a skyscraper, where a gecko is defying gravity. This small creature can cling to almost any surface, thanks to millions of tiny hairs on its feet, each splitting into thousands of even tinier branches. These structures interact with the surface at the nanoscale, creating a type of adhesive force. It's a stunning example of nature's nanotech at work and has inspired innovations such as gecko tape, a super adhesive with a myriad of potential uses. So, as we marvel at the cutting-edge developments in nanotechnology, let's not forget to appreciate the nanoscale wonders that have been part of our natural world all along. From the shimmering wings of a butterfly, to the self-cleaning lotus leaf, to the gravity-defying gecko, nanotechnology is not just a scientific frontier, but a natural phenomenon. Nature, it seems, has been a nanotechnologist for millions of years. So, we've taken a whirlwind tour of the nano world. Let's summarize what we've learned. We began with a glimpse into the nano frontier, where we explored the definition and scale of nanotechnology. We learned that nano refers to 1/1,000,000th of a meter, an incredibly small scale that's hard to imagine. It's like comparing a marble to the size of the Earth. This is the playground of atoms and molecules, the building blocks of everything around us. Next, we dived into the basics of nanoscience. We discovered how scientists manipulate individual atoms and molecules to create new materials and devices. We learned that at this scale, materials can have different properties compared to their bulk counterparts. For instance, gold at the nanoscale isn't gold in color, but can appear red or purple. Our journey then took us to the power of nanotechnology and its applications. We saw how this tiny science has big implications for various fields. In medicine, nanoparticles can target diseases at a cellular level, potentially revolutionizing treatments. In energy, nanotechnology can improve the efficiency of solar panels. Even in the world of electronics, nanotechnology is making devices smaller, faster, and more powerful. We also marveled at natural phenomena at the nanoscale. Nature has been a nano-engineer long before humans discovered this field. The iridescent colors of a butterfly's wings, the water-repellent lotus leaf, the adhesive abilities of a gecko. All these are examples of nature's nanotechnology at work. In essence, the nano world is a place of immense possibilities, where small is not just beautiful, but also powerful. This journey has shown us that by understanding and manipulating the world at the nanoscale, we can create materials and devices that have the potential to change our lives in significant ways. As we continue to explore this tiny universe, who knows what incredible discoveries await us in the realm of the nano?